Hi, welcome everyone. Thank you for standing by with our stream today. And my name's Eric. I'm going to get my camera going here. Send to stream. And let's see. Okay. And start. Thank you for waiting for the technical difficulties here, and I'm just going to be sharing my screen, sharing the camera, and please let me know if you guys can hear me in the with the audio. Please let me know in the comments section while we're getting the video going. I think the audio is going already, so please comment in there and let me know also if there's any questions that you have in the meantime. Okay, great. You guys can hear me. Let's see, basics, privacy schedule. Are you guys able to see my screen yet? I see that you can hear me. Let me know if you guys can see the screen, and we will get started with the webinar today. Stream. Where my video, camera, speakers. No, not able to see that yet. Cannot see yet. Okay, let me try to get us started here. Send the stream, layouts, basics. How about now? Are you guys able to see anything on the screen there yet? No? Let me see if we can hide. Okay. Got the camera. Let's see. Add speakers and content to build your scene. Let's try this window, entire screen. Okay, sorry for the inconvenience there. I have, let's see, add scene, and we've got it going on here now. So let me turn off the screen for now. You just got me for now. I have the audio on and the video on. Please let me know if you can see me here on the main screen. And I will turn on the share screen button once I get a comment response from you guys. Again, sorry for the inconvenience there. We will get you going. Thank you, Andrew, for letting me know. We got the screen share, the video on, and now the screen sharing will begin here. Okay, and now let me know if you guys can see the screen here, and we'll get started on the simulation webinar for today, February 14th, and we'll just cut the rest of the beginning there to get us going on our main page. This will be recorded for you guys to be able to view it again at any time at your convenience. So let me just double check here. Yep, all good. Awesome. So my name is Eric. I normally do the training sessions with BobCAD-CAM, and we are going to be viewing V36 here with setting up a machine setup, setting up your stock, and setting up everything with any machining purposes. We're looking at 3-axis milling today. If you guys could send in the comments, what do you guys normally use? Is it 3-axis milling, 4 or 5-axis milling? We could also take a look at today if anyone's interested, and we'll be taking a look at programming in BobCAD, viewing it in simulation, and all of the neat tips and tricks for simulation there. So let us get started. We have a 3D model here with 3-axis milling on an advanced rough and a finished toolpath here. All right, and we'll start from scratch with importing a 3D model. It could be any of these supported file types, DXF, DWG drawings. I imported this as a step model to begin with. You could also import as an IGES 3D model from other CAD software programs. STL models, Rhino CAD files, SolidWorks part files, and our native BobCAD file type with file extension .bbcd. As a side note, I normally tell customers that are just getting started here with importing as a step model or any other Oops. Are we in the comments section? We're going to reschedule. No, please go ahead and drop from, no, sorry. Are you able to see again here? So we have it live again. Let me make sure you guys can see. I'm looking at the comments here, making sure you're able to see what's going on here. Works now. Yeah, thank you, Andrew, saying it works now. Screen share. Yep, screen sharing with BobCAD open again. Sorry about the technical difficulties, everyone, and thank you for staying with me to view the simulation here that we're going to be going over with this BobCAD file again here. So it's with a roughing and a finish pass. Again, thank you for you guys' cooperation viewing the webinar today. A lot going on with the Vimeo access and communication there. I apologize for that, and thank you for sticking with us here today. So we're going to be going through a roughing operation, sort of a semi-finish operation next, and then a finish pass. And we'll be getting started from scratch here. So with a 3D model here, we can import and then be able to start with a new milling job. So here we go to the top and we go to CAM and start a new job. It'll be a milling job type, and we'll be defining our machine as a certain milling machine here. We're using our generic BobCAD machine here, our BC3X mill. We begin by going to the stock wizard and defining our workpiece, which will be our finished 3D model here that we're working off of. Our next page here will be our stock definition. This is where we are defining our stock that we're starting with. So it could be a rectangular piece of stock here. It could be a cylindrical piece of stock that we're starting with, and I can calculate that. Or it could be any other shape or size of our stock that we're starting with. That can be really helpful if we're starting from a casting, for example, and we need to machine down from that size. We can define that stock size and make sure that there's not going to be any error cutting. Don't want any time wasted with the machining process. So from there, we're also on that last page there. Sorry about that. From the stock page, our last page here, once I go forward, is our machine setup. And this is where we're defining our machine 0, or our work offset at for G54. We can touch off the tool down here at the bottom left corner, or if we're using a probing tool or an edge finder, if we're, for example, touching off at this tool at this location, I highlight the origin point and click on that point for our new G54 work offset location. And that is where we start our milling operations from the machine setup 1 under our CAM tree. So I begin by right-clicking on the machine setup and going to our milling operations. We have our drilling, tapping, counterbore operations. When we go to mill 2 axis, we have all the basic milling operations. We're not necessarily going over today some basic functions. If you guys are more interested in looking at something like this in another webinar, please let us know in the comment section. And some of these include facing off a part, profile rough, profile finish, pocket, engraving, chamfer mill, corner rounding, all the basic operations to start with there. So if you guys are using a router, maybe even a 5-axis router, indexing at different locations for some of these operations, and want to see that in a next webinar, please let us know in the comment section. And let me know in the comment section also if you have any questions going through the webinar today, and I can answer any questions at the end on anything that I may have overlooked with simulation or any questions that you all have there. we're going through a 3-axis milling operation that we are focusing on with the mold of the bottle shape here to begin with for simulation. And so to start with that, I'll actually pause it here at the first roughing operation. We can see the toolpath and see if you guys have any questions so far, and I can answer anything there. Yeah, thanks, Andrew. Yeah, Vimeo, it can be a bit touchy at times, so thank you everyone for sticking with it and getting started here with the Vimeo session here. So let's see. Yeah, looks like you guys. Thank you, John, for letting me know you guys can see the screen now, and we'll get started again. Let me just share the whole screen. There we go. And make sure you guys can see that. Cool. All right. And so we're going to be going through this roughing operation, this advanced rough first. Then then a second roughing operation is sort of like it's a semi-finish pass there. And then a finish pass for the planar toolpath. So, excuse me. So from here, I right-click on Machine Setup and go to our milling operations. We go to Mill 3-axis. We select our geometry and select a boundary. So we start by selecting geometry, selecting a solid model, and then containing the toolpath inside of a boundary where I can either select solid edges here all the way around, or I could chain select with wireframe. I don't have any wireframe with this 3D model at the moment. So what I can do is I can also chain select surface edges by right-clicking on a surface edge and selecting constant Z. Everything here is in a constant Z level here. It's on the same plane in Z there. And I will click OK. We go through to the next page here with setting up our operations list. We have an advanced rough. And I did a second advanced rough with a smaller tool after that. And so to do that, I highlight the advanced rough here and add another in the current operations list. And then I did a planar toolpath you can see on the left-hand side here. And so I scroll down to the advanced planar and add that at the very bottom. So we have a rough, another rough with a smaller tool that I'll be using, and then a planar toolpath for a finish pass. When I hit the next page, it will auto-update all of the operations here on the left-hand side that I can move down to with each of the tools there. So I'll go to the first advanced rough here, and I'm using, actually what I'll do is I'll go to my advanced rough here that I had already created, where I'm using a 1/2-inch flat end mill. I can set the RPM at 5,000 revolutions per minute, and then a cutting feed rate of 40 inches per minute and a plunge feed rate of 40 inches per minute. So those are the feeds and speeds that I'm using for this tool. I go to the next page where I'm using an adaptive roughing operation. Now the adaptive roughing is our tricoidal milling. It's a high-speed machining operation where it will keep constant tool engagement the whole time. Our next page is where, and then so this next page is where we can set the depth of cut and step over amounts. An allowance, so we're leaving 15 thousandths of an inch for a finish pass to clean up. Our lead in and lead out, our entry options here, we can plunge down in with the tool. We can ramp in with the side of the tool here, or we can do a spiral entry, which would be a circular interpolation, a helical interpolation. Our next page options, we have a rest roughing option. Or if I had a previous roughing operation from this one, I can set the previous tool diameter and corner radius. The software will calculate any areas the previous tool could not fit into and calculate just that tool path for us. So essentially it will start right from where we left off from the previous operation and avoid any air cutting this way. Our next page, we have stepping over with linking, a direct link, step over there. Gouge check page, we can make sure the tool and the tool holder does not gouge into the workpiece I've defined here. So make sure there's not any collisions with that on this page. And then there's some other optimization options here with our advanced feed rates, our MDI page where we can manually add any data as well into the G-code. And those pages we can skip for now. We can always go back to it. If you guys have any questions with any of those pages, please let me know in the comments section. I can answer any questions you guys have here in the webinar today. And we'll be going over those in a later webinar of advanced feed rates can be very useful and some other optimization options there. So here's where we're setting our next roughing tool. It's going to be a 1/4 inch flat end mill. Setting up our spindle RPM at 5,000 inches per minute. Cutting feed rate of 20 inches per minute, so half of what we did last time from the previous operation. Another adaptive roughing operation, and it's just going, actually I think that's the next page here. Nope. Our parameters first, we're doing a depth of cut and step over at 100 thousandths, half of what we did last operation. We can do a helical interpolation on this one as well. And then here on our options page, this is where we have our rest roughing operation. So from the 1/2 inch flat end mill, it's going to rough out as much as it can. And then with the 1/4 inch end mill, it's going to start right from the previous roughing operation and mill out everything that it can do. We have other options for, if I go back to this page, sorry to jump around here. If we go back to this rest roughing option, we do have other options like operation stock that we'll look at with the simulation here next. And then all of these pages we went over before, our linking for each step over, our gouge check page, our advanced feed rates and MDI page. And now we're at the advanced planer tool here. We're using a 1/4 inch ball end mill, so it's a 1/4 inch diameter and an 1/8 inch corner radius. It'll be 5,000 revolutions per minute, cutting at 20 inches per minute with the cutting feed rate and plunge feed rate, plunging down in. We have our cut pattern going back and forth and the angle direction here of 90 degrees, which will go back and forth vertically along the y-axis. If I set it to 0 here, it'll go back and forth horizontally along the x-axis, and I can do anything between 0 and 360 degrees here. For example, if I set it to 45 here, it'll do a 45-degree diagonal cut back and forth across the pocket there. We have our step over here of 100 thousandths. Our entry option, I'm just going to be plunging in with the rest of the material that we have left over. And then we have a rest machining option here, where we also have that rest machining option, setting the previous tool here of the 1/4 inch flat end mill, or we can use an operation stock, which we'll go over once we get into the simulation here. So in the next pages, we have those other pages that we went over before, the linking for each step over, the gouge check page, the advanced feed rates, and the MDI page last year. So I'll just finish here because I've already computed this tool path, and I'm going to highlight each operation here. the first advanced rough, the second advanced rough, and then the advanced planer here as well. So we'll just turn on all of these operations and take a look at it. I'll save the file here to start with, and then take a look at it in the simulation for all of these milling operations. So to start that, I hit Start Simulation up at the top. Before I click on that button, actually, as a side note, we will go to opening the simulation as a separate window. That's a new feature in V36, where I can go to File, go to Settings, and then under the CAM page here, we have this option for simulation window as a separate window here. I can hit Apply, and then OK. And then when I open the simulation, it will be in a separate window here. Okay. Yeah, so while simulation is opening there, just looking at the comments from before. Yeah, thank you, Angie, for letting me know. You said 4-axis. Very interested in 4-axis simulation, and anything 4-axis I'll share. Yeah, so we're looking at 3-axis at the moment, and towards the end of it, we'll take a look at some 4-axis since you're commenting in there. Anyone else engaged in the comment section there, please let me know. I can answer any questions and go over anything that to tailor to what you guys are interested in looking at today. So first we'll look at this 3-axis toolpath here, the first roughing operation here in our separate window of our simulation. So you can move this to a second monitor, and you can actually, as you can see here as I highlight these milling operations in BobCAD, I can also be simulating at the same time. So do some sort of multitasking that way. So first we did the milling operation. The first roughing operation. Now we're getting into the second roughing operation, cutting into the extra area from the first roughing operation. Yeah, good question, Mark. What simulation features are available with 3-axis Pro and Simulation Standard versus the Simulation Pro? Now, the Simulation Standard is what we're currently looking at, and I can show you up at the top here with this drop down. We're focusing on the workpiece and the stock view here. If I drop this down and select Machine, we're actually looking at the whole machine here. And so if you have a 3-axis mill like this, if you have 4 or 5-axis mill, you'll be able to see every component of the mill and be able to make sure that there's not any collisions with the machine there. That is in the Machine Simulation Pro, which is included in the 4 and 5-axis milling packages. So we'll skip the next this next roughing operation and get to the planer toolpath here. So we can see here with the planer toolpath, it's just going to go back and forth across the surfaces there. at 100,000 step over. Thanks, Matt, for your comment. Mill turn simulation, especially multi-turret and multi-chuck machines. That's a great comment. I will. We can take a look at 4-axis milling and also look at mill turn. We could look at a simulation of that as well with the Machine Simulation Pro, as we just saw with the 3-axis milling. Okay, so once I close out of that, I can start with another nice feature, very useful feature in the simulation. I'll make this larger here. And if we look at the green tab down at the bottom right that I click on, called Analysis, I'll open up that tab. Go to the drop down here under Analysis. The fourth one down is Deviation. And I'll hit Refresh, this red refresh button to the right of it. It'll refresh the colors here on my stock model, depending on how much material is remaining. Now we can see here the holes are in blue because we haven't drilled the holes out yet, so it's not cut to size from my workpiece. And if I zoom in here, most of it's in green, but we can see this teal color is the next color here, which is more than our cut tolerance of plus or minus 8 thou remaining. So it's showing there's about 10 thou remaining on with the peaks of everything here. And getting into the corners of this dark blue, there's more than 64 thou remaining in the corners to cut out. And so that is a great verification tool here, our deviation page, to make sure that everything is cut to size before we run it on the machine. So I'll close out of simulation here. We'll go back to the main page. There we go. And then, so we have, what do we have next? So first, first we could take a look at the planar toolpath. I have a 1/4-inch ball end mill. Let's cut it down in half to an 1/8-inch ball end mill. And cut down the step over from 100,000 step over to maybe we'll do 20,000 step over. And you can see every time I'm done with my selections here, I'm normally hitting finish rather than compute. Good side note here, the reason for that is instead of hitting compute and computing all 3 of my milling operations each time and waiting for all of them to compute again, since I've only made changes to the planar toolpath, I'm going to hit finish, and I'm going to go to the cam tree, right-click on my advanced planar and compute it there, so that I'm only computing that one individually rather than computing all of the operations all over again. So we'll go back to the simulation here, and we'll take a look at the roughing and then the planar toolpath. Check your guys' comments here, see if you guys have any more questions. Yeah, a lot of good questions in there, guys. Thank you Andrew, letting me know interested in the NC Editor Pro. You can take a look at that also here towards the end. A lot of good stuff to go over today, and a lot of good content to go over in our next webinars. Now, our webinars are every other Wednesday, so the next webinar from here will be on the 28th. Same time, 1 o'clock p.m. Eastern Time. So here's a roughing operation, then a planar toolpath with the 1/8" ball end mill. And once that's done, we'll go back to the deviation report here. So again, I go to that analysis tab here in green. The drop down is deviation and hit refresh. And now I'm zooming in more and more. Everything here is in green. Going to the sides here, this blue color, we're looking at about 20 thou remaining in the corners. You may need to use, I don't know, a hand tool, something to get into the corners a little bit better there than the ball end mill. That's the radius of the ball end mill there. So it's great cut to size. The side walls here, maybe we could do another pass to finish those off, but yeah, it's a great verification tool to make sure everything is cut to size before we run it on the machine. So next will be operation stock. So let's go to that one here. I'm going to blank all the toolpath out so we can kind of see something that's going on here. I'll highlight our second advanced roughing. The duplicate one normally comes in as advanced rough 1. I normally right click on this one, go to rename down at the bottom, name it advanced rough 2, make it a little easier to understand there. Now we're looking at all of this air cutting here, and to eliminate that, again, we have that rest machining option under options here. We also have an operation stock to show you. So if I drop down the operation here, advanced rough 2, you can see this here under boundary for each operation. We also have drill tip positions, just as a side note. If you wanted a plunge point, you can create a point and define it as where you want to start the roughing operation at, and then operation stock. So that is a 3D model that we're going to be working off of and doing the roughing operation from that operation stock, from that stock that we're starting from. And to define that, I'm going to turn off the advanced rough. I'm going to turn off the planar. We're just going to simulate the first advanced rough here back in simulation. And this is an easy way to save your stock of what you have left over for operation stock for the next milling operation. You can also save it. You're saving it as an STL file. So you can save your model as an STL file and you can 3D print it. You can save, maybe if you did a tapping or a threading operation, you can save the STL file to save the 3D model of the thread as well. And I can show you here once we run through that milling operation. Now we're looking at it here. We're looking at that yellow tool path. It's just the surface here. It's just showing that's the first operation number basically. I can turn that off, excuse me, by going to the drop down and selecting none here. And that's under the analysis tab. Now if I tab over to cut sim, we can select this first icon here of a floppy disk, and it is to save stock. So we can save this stock as an STL file. Once I click on it, I can name it and save it as an STL file on my computer. I've saved it as operation stock here, and I hit save. Then I'll close out of simulation, and I can use this model as what I'm starting from for this advanced rough 2. And so I'll go to operation stock. I can right click on it and reselect. As a side note also, you can see this red plus next to each one of these options. When there's this red plus icon, it means that there is nothing selected for that option. So once I right click on it and go to reselect, I can select a solid model that is defined here in the file, in the BobCAD file, or I can import it from an STL file. I can click Browse and select that operation stock STL file. You can see it highlighted. You can see it a little better once we click OK. And we highlight operation stock. I can hide the solid model, my workpiece, to see just our operation stock in a transparent color here with that stair stepping from the previous roughing operation. So that is our defined operation stock that we're starting with. If I right click on Advanced Rough 2, go to Compute Toolpath, you'll see, let's see, helical ramp. It's not like in a certain parameter in here. So I'll go to one of our other advanced roughing operations here. Oh, come on. And I'll plunge in here. How about that? I think I can write it. There we go. So here is the advanced rough number 2, the remaining toolpath that we're starting with from the previous roughing operation with our defined operation stock. So basically BobCAD is understanding, okay, this is the stock that that is remaining for this roughing operation, and this is the toolpath to mill out as much as possible with that 1/4 inch flat end mill with the step over and step down that I have set up of 100 thousandths. And then I could even go into the advanced planer after I've done the simulation of the advanced rough and advanced rough 2. I could save it and use the operation stock for the saved STL file after simulation for the 2 roughing operations. So a lot of great features in our simulation to be able to save as an operation stock is really useful. To be able to start right where we left off and avoid any error cutting possible. That's under the Cut Sim tab here. And then I always use the Analysis tab and go to Deviation to show different colors depending on how much material is remaining to get down cut to size for our workpiece here. In our simulation up at the top here, it's showing us our estimated cycle time. So it says 1 hour, 1 minute, and 17.1 seconds. That is based on the 40 inches per minute of the first roughing operation, and then the 20 inches per minute on the other 2 operations there. That's about it with the simulation I'm showing with the 3-axis milling operations. That can be really useful. Please let me know if you guys have any questions on that, and I can answer them in the comment section below. Let's see. So yes, Andrew, NC Editor Pro. Yeah, Andrew, good question. How to load a machine in to see it other than just the basic BobCAD 3-axis mill. We'll take a look at that. Can you use equidistant toolpath on 4-axis Pro? That's a good question. I'll show you that real quick. We don't have equidistant as 4-axis necessarily. You can't wrap it around. That's a good question, though. If you go to Machine Setup 1, we'll take a look at a little bit of 4-axis today. If we go to Mill 4-axis Rotary, we have the Advanced Rough and the Advanced Finish. The advanced finish is a really useful one where you can zigzag back and forth, and we do have a where you can machine the flat walls, the flat areas there. So that would, we don't have a spiral toolpath necessarily like equidistant, but that would be something that you could use for a finish operation in 4-axis. But good question there. And so, Mark, can you clarify why Operation Stock Use generates an error message that the tool needs to be smaller? Tool needs to be smaller. Oh, okay. Yeah, good question. So if we go back to the feature, Advanced Rough, uh, our Advanced Rough tool is a 1/2-inch flat end mill. If we go to the options page for rest roughing, and it's the same exact tool, BobCAD will give you an error message saying that the previous tool has to be smaller than the tool you're using. Otherwise, you've already machined everything with this tool from the previous operation, and the software won't give you any tool path because everything's been machined. It'll all be error machining, is what it thinks. So that is the answer to that one. Yeah, Matt, that's a good feature request. Saving as something other than an STL so that you can manipulate the 3D model from there. I agree. That's a good one. I'll make sure to note that down. That's a great feature request there. Is there a simulation setting that will observe changes in the setup's safety position? Not sure exactly what that is, Matt. If you want to explain a little bit further, observe changes in the setup's safety position. I don't know if that has to do with the clearance plane or rapid plane, but we can take one thing that does remind me of is when we go into simulation, we'll take a look at the machine, and I don't know if anyone noticed this before. You can see the with the machine simulation, the stock is sitting inside of the table by default. And the reason for that is because our machine setup that I have set up at this corner will be sitting on the table by default. So to raise that up the extra 2 inches of the stock thickness, I'll have to, I'm not changing the machine setup at all, but I am changing the location of the stock here. And to do that, I can close out of simulation here. I can right click on machine setup 1 and go to edit. All the way down at the bottom here, we have work offset XYZ. So this X value, Y value, and Z value will move this location in the simulation. As a side note, it doesn't change anything in the G code. So if I raise this up 2 inches, it's not going to raise up the Z location in the G code. It's only going to raise up this location in simulation. So I click OK, I show simulation, and I show the machine here. It'll raise everything up that 2-inch distance there to get it raised up out of the table, for example. So what I did was the work offset is in simulation, went from here up to the top there. And also, all of as a note with one of the comments you guys have there with setting up a machine, the table, the the spindle, and everything else with the machine here is an STL file that has been modeled, and I can show you how to define this machine, the basics on how to start that. So I'll close out of simulation. And to begin that, I'm in the generic BobCAD 3-axis mill here. You can see the machine is BC 3X mill. If I drop this down, this is the post processor, the file that'll format the G-code specific to the controller that you're using. This is the BC 3X mill post processor, and that is a Fanuc-based post processor. So it's a Fanuc-based G-code that will be formatted there. And so to change the machine here, or change the components of the machine in simulation, I begin by going to the very top in the CAM tree, right-clicking on CAM defaults, and going to current settings, the third option down there. I first have to select the machine here. I'm selecting the BC3X mill, and I can save that as a default machine for each time around. So if you guys are using a Haas machine, for example, you can select Haas 3-axis mill and click Save as a default, so that every new milling job, it will already default to the Haas 3-axis mill machine and Haas 3-axis mill post processor. Now once I have my machine selected here, I can go to the next page here on the left-hand side called Machine Definition. Here's where I can change the limits to my machine. If I highlight X, highlight Y, highlight the Z direction, I can change the minimum and maximum limits here. So here in X, I have plus or minus 28 inches of travel. In Y, I have plus or minus 12 inches of travel. So if I created a milling operation where it's going more than 12 inches in the Y direction and try to simulate or post the G code, BobCAD will throw an error saying, you've gone too far, you have an over travel in this direction, in this amount, go back and fix it. Now, if we look at, for example, under X, you see table, and you can see workpiece transform. You can expand that, and here's some different options. Let's see, we have, okay, yes. So here is the table. Yep, so just above workpiece transform, we can see table. And you can see that this is an STL file that we have here. And I can always modify it if I click on the three dots next to the STL file here and select a new STL file, and it will be, how will I explain this? It will be located in simulation based on where you have it in the CAD geometry location here in BobCAD. So everything's sort of an assembly in that way. Everything has to be modeled and in the right orientation and at the right location in the CAD geometry there. So I'll go back by right-clicking on CAM defaults, go into current settings, got my BC3X mill, I can go to machine definition, and if you've created a new machine here, for example, if we go here to add, make a 3-axis machine here and name it, you would go here to machine definition, your X, Y, and Z will be blank here, and you can right-click on each one, and you can add geometry. So this is how we created the table here by right-clicking on X, selecting Add Geometry, and that table will then move in the X direction, positive and negative directions there. That's how you have a chuck to be able to move, rotate around in the A axis. For example, I would right-click on X, I would go to Add Rotational Axis, select A axis. You can see where it has an A axis now under X. I can right-click, add geometry for the chuck, and you can also see the limits is plus or minus 1,000. Now that's in a degree amount for your 4-axis there. What it'll do, if it goes to that travel limit, it normally doesn't give you an error, because what it'll do with the 4-axis there is the tool will retract, the part will rotate back to 0, for the tool to come back down and mill again, so that there won't be any over travel in that direction there. But what you can do under the A axis here, you can right click, you can go to add geometry, and you can create the geometry for your chuck that you're using for the rotary table there. So that's how to get started with modeling the machine. And please let me know if you guys have any questions. I'm glad you guys are interacting here today. Thank you guys for asking all these great questions here for the simulation. All right, so now we can also get into the NC Editor Pro for a second here. Use equidistant toolpath. Good question, Mark. So, what is the machine definition? Uh, what is the machine definition enabling the sliders for machine parts and simulation? Let's take a look at that in 4-axis, actually. So we'll go to 4-axis real quick, then we can take a look at maybe a mill turn machine and also answer the NC Editor Pro questions. So with 4-axis milling for simulation, we're at rotary. This one works here. We've got our BC 4-axis mill with an X-axis rotation. You can see the rotary toolpath here. And the question was, what are the sliders for in the simulation to move the axes back and forth? Now that can be helpful for the A-axis rotation especially. You can see all of the passes going across here with the tool coming down and then the part rotating multiple times there. Pretty much like you're turning down the stock, but you're using a milling tool here with a rotary table. We'll go into simulation. You can see the stock is inside of the chuck this time, so we'll go back to that page under machine setup to move it out of the chuck here. Now, this is all in relation to our XYZ axis right here in the bottom left corner. So what I need to do is move it out in the negative X direction. So I close out of simulation. I right click on machine setup and go to edit. And then at the very bottom, we have work offset XYZ. I'm going to move it in the negative X direction this time. We'll say negative 12 inches, a pretty long piece of stock here. So I'll click OK, and then go back into simulation. All right. There we go. So zoom in. There's our stock sticking out of the chuck there. Maybe I could do like 10 inches or something so that it's being held in there. You get a great idea of the once it's running here, the chuck rotating around there. That is under axis control. So we went over cut sim, we went over analysis. We'll go to axis control here, where I can move these sliders where we can move this back and forth in the positive or negative X direction, the positive or negative Y direction, positive and negative Z, and the positive and negative A direction, which we're just rotating the rotary table there. I think once we hit run again, it goes back to the correct locations. Everything is grayed out here. I can't move it now because we're actually simulating now. Once I pause again, we can always move these around so we can see see how much travel we have or how much space we have so that there's no collisions in any of these directions. And we'll be able to see that once it gets to the positive or yeah, positive 10,000, just before it'll be about positive 9,000. We are getting into the positive numbers now in the a-axis, 4, 5, 6,000 degrees. Once it gets to about 9,900 degrees, you'll see the tool. Let me pause it here. The tool retracted all the way up to a safe clearance plane, and the chuck is rotating backwards. It's a retract of the tool and a rewind of the rotary table, so that the a-axis, we'll see it's going to go, the slider is going to go all the way back to negative 9,000. So essentially we have 20,000 degrees of travel in the a-axis. We get a lot of questions of, well, why can't we just have an infinite number there? The only, I've been thinking about giving a good answer for that. The best answer I could give is because we always need to know that coordinate location, you could say. We always need to know that a-axis location, so that if there's going to be any indexing on the part, for example, we need to go to a 90 degrees on one side of the part. We'll always know that a-axis location so that we can reference it for another milling operation. And a lot of machines have limits to the a-axis for that reason. And that's why we have it at plus or minus 10,000. If it's a larger number for your machine, again, you can always change that, change those limits by right-clicking on CAM defaults. Go to current settings, select your machine, which will be the BC4X mill. Going to machine definition on the left-hand side, clicking on the a-axis here and changing your limits of plus or minus 10,000 degrees here. I don't do a whole lot of other changing here because this can change values in the G code, the initial value, the center point, the direction, things like that. I leave all of that alone. I may change the limits here to the machine, but that is about it. And the geometry here is, these are great generic machine files to be able to look at for a 3-axis milling machine, for a 4-axis milling machine, and also for mill turn. We'll take a look at a machine here real quick with the mill turn and answer any other questions you guys have with the simulation here. Before we get into mill turn, that's sort of straying away from what we had on the docket for today. I'll also show real quick changing your machine setup here. So this is a very basic option here of, if you're doing a bunch of milling operations on the top here for the mold, then maybe you want to flip it over to do the drilling operations. You can right-click on Machine Setup 1. You can go down to the bottom and go to Additional Functions and go to Insert Setup. This is where we can create another machine setup. It's Machine Setup 2. It starts at the CAD origin here, and I can change it by right-clicking on the machine setup and going to Edit. And at any time, I can edit a machine setup this way by clicking on this box under Origin. I'm highlighting the Origin box here. I can revolve the part around and change the origin location there. Now Z-axis is pointed down. I want it flipped there. We have these reverse direction options, so I can easily just reverse the Z-axis that way. I want to reverse the X-axis to get everything in line there. And then with these boxes, we can also change the directions of the X, Y, and Z axis. So with the X-axis here, I can select a line or a surface edge or a point going in the direction of my new X-axis. So if I want the X-axis to be pointed in this direction, I just click on this point. You can see it changes to that direction there. If I'm at a 45-degree angle for whatever reason, I can highlight the box again and click on that point. That's going directly at a 45-degree angle there. If we're on a compound angle, you're fixturing your stock a little differently there at whatever angle degree. You can always create uh, any sort of geometry and select a line or select a point in the direction of your X, Y, and Z axis. And maybe if you selected a line here and it's going the opposite direction there, you can always select reverse direction. And so I'll highlight this one again for my X direction there. So we flip the stock over and we can do a drilling operation for some of these holes, for example. In the simulation, it'll show everything. It'll show the stock being flipped over, and in the G code, it'll also have a stop in the program for you to be able to refixture there. Now we can get into the mill turn simulation. Very similar to the 4-axis milling, just a different machine type, and it looks pretty cool. So we'll go here to mill turn. You can see all of these operations here. We're starting with facing and turning down the outer diameter of the stock here with a lathe, and then doing some milling operations on the side of the part and on the front of the part here. We'll take a look at our simulation and see what's going on here. There we go. Now it's going to open up our simulation and show a mill turn type of machine. Let's try that. Now, good question. Can I do what I just did in the NC Editor Pro? Now, the NC Editor Pro is for 3-axis milling and for lathe G-code to be able to backplot that. Not necessarily for multi-axis at the moment, but we'll be coming out with that where you can view 4 or 5-axis milling and also mill turn to be able to backplot the G-code specific to what that is. Let me try that. See if you guys have any other questions so far. Yeah, good point, Mark. Work offset XYZ. We could rename to work offset XYZ for simulation only. It's sort of implied there, but that's a good suggestion there to be able to. It is in our help topics page. If you go to BobCAD-CAM help, it'll tell you all of the definitions there. But yeah, good thing to know is that it is in simulation only, and changing the work offset XYZ in machine setup, it doesn't, at the very bottom, it doesn't change anything in the G code there. So here in mill turn, we have our, let's see what machine this is. This is BC2T2S. So this is our BobCAD 2-turret, 2-spindle machine. You can see in the simulation there. Oops, there we go. You can see in the simulation here, 2 turrets, 2 spindles, so a main spindle, sub spindle. We're able to transfer the part over if you need to. We're able to program on different turrets here. But yeah, we're able to see the tool here coming down, doing a facing operation, and then doing some milling turning down the outer diameter of the stock, and doing some milling operations. Let me see if you guys have any questions with the mill turn there. Mill turn, mill turn. And you can see that red it's showing when it hits the spindle there of the main spindle with the turning tool. It'll show that there is a collision there. So we'll either want to have the stock sticking out a little bit further, maybe an extra amount of stock there to be cut off, or something like that. Let's see. Let's see. Oh, good. All right. So this is turning down the outer diameter of the stock, doing some milling operations on the front face of the stock here, and we are able to, go into the deviation just like before, and also use these sliders here on the right-hand side to view any movement of the turret and of the spindle to make sure that there's no collisions and see what sort of travel we have there. I know a couple of you guys had some questions with the mill turn. Let me know if you guys have any questions with looking at this here today. I think you guys had some questions with modeling the mill turn machine. That's a little more complex than with the 3 or 4 axis milling, but it's the same concept and the same workflow, where we can close out of our simulation here. And to model all of the parts in here, the components, again, we right click on CAM defaults, go to current settings, select one of our mill turn machines in here. So BC 2 turret 2 spindle. We could save that as a default for a mill turn machine. It'll be different. You can always save a default milling machine here. You can save a default turning machine, and you can save a default mill turn machine. You could also save a default wire EDM machine here, and they will all be separate default machines when you're selecting your machining job. So with the BobCAD 2 turret 2 spindle, you can go here to machine definition, and here's all of the components for the mill turn machine. Let's see. If you go here to the C axis, this is the chuck wizard, where you can define your chuck. You can define it as an STL file, or you can type in the components right here, the parameters, and also of the jaws here, and type in all the parameters here. And you could also import it as an STL file. So that's a nice one to look at there. You can also go to the turret towards the bottom. Turret mount. We also have, so here is UT for upper turret. If you go down towards the bottom here, there's LT for lower turret. And there is a turret wizard where you can type in the number of stations. You can type in the thickness of the turret, and type in all of the geometry of the turret here as well to view in simulation. This can be really helpful if you have a mill turn machine and you are making sure there's no collisions between anything on the turret and any other components of your machine there. So let me know if you guys have any questions with the mill turn. We'll go back to the, I can answer some questions about the NC Editor Pro here. Let's see if we get NC Editor Pro to open here, and Nance. Let me see if you guys have any questions with that. Let's see. So, Matt, good question. Is there a way to get the G53 safe positions to be observed by the simulation? Yes, so I believe it's in that same location there. G53. I believe that's under the current settings and under machine definitions. Let's see. Base. Yeah, so are you referring to the limits here with machining, minimum and maximum, or are you referring to the home position of the machine? Because if so, I don't think we have a an option for that. The machine zero location, you could set that up as a feature request for the specific location of where it starts at. But for a safe clearance plane for your machine, you can right click on machine setup one and go to edit. And here, work offset, at the very bottom here, under work offset number, where you can set it to number 1 for G54, 2 for G55, 56, and so on. At the very bottom, you have a clearance plane. It'll retract to a safe clearance plane for each milling operation of 1 inch every time. And you can change that clearance plane here in between tool changes and in between any milling operation. So let's see here. If we have our NC editor, we have our NC editor Pro option to be able to backplot G code line by line. And it is different. We'll understand the differentiation between the backplot in BobCAD and the backplot in the NC editor. So if I go back to BobCAD here, in each milling operation, we'll take a look at our first advanced rough that we did today, and we can simulate it at the top to view the material removal for each milling operation. Take some time to open simulation, close out of it, refresh the simulation. We can view each milling operation in the CAD workspace here with our CAD geometry by right-clicking on each operation and going to backplot. So with that backplot functionality, really what it's doing is we can step through line by line. We can hit play up at the top or pause it, and we can go to the next step forward for each pass there, or for each move. And I can play through it. We can see the shaded, transparent for the tool, or wireframe to be able to look at it from the top and make sure the side of the tool isn't violating any of the walls here. We can also view just the tool if we wanted to. The flute, shaft, show the arbor, show the tool holder. So we can show all of that geometry now if we just want to see the tool and see if there's any gouging there. And so the difference between the backplot here in BobCAD and the backplot in the NC Editor Pro is that the NC Editor Pro actually reads the G code line by line and will simulate it based on that. Here it's only simulating the visuals of the toolpath. So if there was any discrepancies in the G code here, the backplot here doesn't actually read the G code line by line, so it wouldn't show you any sort of gouging or collision from the G code posted program. If I generate the G code here, right clicking on milling job and going to the NC editor, it will actually backplot the G code line by line and show you any discrepancies here in the NC editor. All right. Now let me go back to the comments section and see if you guys have any other questions. Right on the job. Right click. Let's see, advanced posting. Advanced posting. No, sorry, Matt. I don't see the advanced posting option you're asking about. Oh, the advanced posting, that is done for your specific machine. Advanced posting files are for specific machines that I'm not using here today. Just the BobCAD milling machines. Current settings. Current settings. Advanced posting. Current settings. Advanced posting. Yeah, see, we have multi-axis posting where you can set certain limits, but the advanced posting, that's only on certain machines that we can go over at a later date. But we're focused on just the BobCAD milling machines for simulation and the mill turn machines also. Yeah, it's not on there for the generic BobCAD machines. Now, please, this is about it for the simulation today. Saw a lot of great things in the simulation window here. Being able to view it in another window is a great thing on its own. But also being able to look at the machine and the Machine Simulation Pro, being able to save the stock as an STL file here and open it as an operation stock to be able to start right from where we left off. Under the analysis page, we looked at the deviation report to be able to view how much material is remaining based on our workpiece that we have defined to see if there's any remaining material from the stock left over there. And also our tool axis control here to be able to view the movement of the tool, movement of the table of the machine, and make sure that there's not any collisions between any of those movements and any other components here in simulation. We also viewed how to begin modeling, defining a new machine and defining the components of that machine, the spindle, the table, and everything else that we're able to define there under the machine definitions page. Also the limits in X, Y, Z, and A-axis movement. So please let me know if you guys have any other questions overall with the webinar today. Thank you all for taking the time out of your busy schedules to view the webinar, and thank you for viewing the webinar today. Holding on for the first few minutes of the technical difficulties there, the Vimeo getting set up here. Thank you all for viewing the webinar today, and hope you guys have a great rest of your day. We'll be viewing another webinar here, same time, 1 o'clock Eastern at on Wednesday, February 28th. So not next week, but the week after, we'll be having another webinar here with answering all of your questions and going over a certain topic that is tailored to what you guys are asking. So please let us know in the comment section what you're most interested in looking at next time, and we'll be going over that February 28th. Thank you, everyone, for viewing our simulation webinar today, and have a great rest of your day.